Chapter 4.1, Apply Triangle Sum Properties. A triangle is a polygon with three sides. A triangle with vertices A, B, and C is called triangle ABC, or you just put the triangle symbol and write ABC. So as far as classifying triangles by sides, remember that congruent means the same measurement. In the case of sides, it's going to be the same length. But anyhow, a scalene triangle has no congruent sides, okay? So 0 sides are the same length or congruent. An isosceles triangle is at least 2 congruent sides. So in other words, the number of congruent sides is going to be 2 or 3. All right, these red tick marks right here indicate that these two sides are congruent. But you might not know the length of the third side. So the isosceles triangle is at least 2. Okay, it could be 2, it could be 3, because you might not know the length of the third side, but if you have at least 2, it is isosceles. Equilateral triangle, all 3 sides are congruent. Okay, so that's 3 congruent sides, and you can see them with the 2 marks on each side. So equilateral. Now we're going to classify the triangles by angles. So for an acute triangle, it's going to be 3 acute angles. Okay, if you remember acute angles, they run between 0 degrees and 90 degrees. Okay, it has to be in between those two. An angle cannot be 0, and 90 degrees is going to be a right angle. So an acute triangle has 3 acute angles. And a right triangle has 1 right angle. Okay, we know what the right angle looks like. The symbol right there is for the right angle. And we'll get into it later, but a triangle cannot have more than 1 right angle, because the 3 interior angles have to add to 180. So if one angle is already 90 degrees, another angle can't also be 90, because that would add to more than 180. But with the acute angles, they're all less than 90. So that's why the acute triangle has 3 acute, but the right angle has 1 right. The obtuse triangle has 1 obtuse angle. All right, so it just has 1 angle that's greater than 90 degrees. If you remember obtuse, it runs between 90 degrees and 180 degrees. Okay, not including 90 and not including 180. 180 is a straight angle, if you recall. And finally, an equiangular triangle is when all 3 angles are congruent. Example 1, classify the triangular shape of the support beams in the diagram by its sides and by measuring its angles. All right, so here's our triangle. See if you can classify it by its sides and then classify it by angles. Okay, so if we classify it by sides, we can see the 2 tick marks right there and right there. Okay, there's nothing on the third side, so at least 2 sides congruent is considered isosceles. And if you do it by angles, we have 55, 55, and 70. Those are all under 90 degrees. Those are all acute angles. So 3 acute angles is considered an acute triangle. So this triangle is both isosceles and acute. Example 2, classify a triangle PQO by its sides, then determine if the triangle is a right triangle. So let's start by classifying by sides first. Okay, I'm giving you 2 of the sides. This side right here is 6.7. And this side length right here is 2.2. I want you to use the distance formula or Pythagorean theorem and find the distance from here to here so you get the length of that side. Okay, using our distance formula, we have the square root, and we're going to do change in x first. Unlike slope, the order doesn't matter, so I'm just going to do 6 minus -1. Okay, so in parentheses, 6 minus -1, and that is squared. And then the change in y, we can just do 3 minus 2. So for the change in y, 3 minus 2. And that is squared. Okay, we'll do the square root first. The two negatives make it positive. So 6 plus 1 is 7, and that's squared. 3 minus 2 is 1, and that's also squared. 7 squared is 49, plus 1 squared is 1. 49 plus 1 is 50. And I'm going to do this on the calculator and round to 1 decimal place. All right, on the calculator, radical 50 is approximately 7.1. All right, so that is the final side length. All right, that's going to be a 7.1 right here. And none of the side lengths are congruent. They are all different lengths. So the word for that kind of triangle is called scalene. Now, the second question they asked is if the triangle is a right triangle, yes or no. Now, looking at this angle right here can't be a right angle. And this one here, it just doesn't look like a right angle to me. The only one that could be is this one right here. So I suggest you try to find the slope of this line and this line and see if they are negative reciprocals of each. See if they are negative reciprocals of each other. All right, so finding the slope, I'm going to go from this point to this point here. So let's count the x direction. 1, 2, 3, 4, 5, 6. Okay, that's positive 6. And going up, we have 1, 2, 3. That's positive 3. Okay, so the change in x was positive 6, and the change in y was positive 3. All right, so the first slope, M, we'll call it M1, and we'll do change in y over change in x. So that's going to be 3 divided by 6. Okay, and reducing that, 3 divided by 3 is 1. 6 divided by 3 is 2. That's one line. Okay, that's this line here. Now let's do the other line. I'll do it in a different color. All right, we want to go from here to here. So first, let's count in the x direction. Okay, from here to here is 1 unit, but we went left, so that's -1. And then to reach this point here, we're going to go 1, 2 units up, that's positive 2. Okay, so left, right is the change in x. And up, down is the change in y. All right, so the slope of this other line here, change in y, we said positive 2. Change in x, we said -1. And 2 divided by -1 is -2. So I think those are perpendicular slopes. Let's see. There's 2 steps. To find the negative reciprocal, you flip it. So we take either one of these. I'll take the 1/2. Flip it. That becomes 2/1. And change the sign. This is positive. This is negative. Does negative 2/1 match negative 2? Yes. That means they are perpendicular. Okay, so since this is a right angle here, since they're perpendicular, that means that this is a right triangle. All right, so we proved that the lines are perpendicular. So that proves that it has a right angle, which means it's a right triangle. All right, so the three angles inside of a triangle, those are just called interior angles. And the angles outside of the triangle are called exterior angles. Okay, and you can only extend one side at a time. All right, so for example, if you extend this side right here, then this is an exterior angle. If you extend this side right here, this one here is exterior. If you extend that side, this one here is exterior. You can't extend two sides and say that this angle in here is exterior. That is not an exterior angle. Okay, it has to be one side at a time. So same thing here. You extend this side, you get this angle. You extend that side, you get that angle. This one right here, the angle that's made by both sides being extended, that is not an exterior angle. So just be careful. Theorem 4.1, the sum of the measures of the interior angles of a triangle is 180 degrees. All right, so these three angles here, we have angle A, angle B, and angle C. Those are all interior angles, and if you added all three of these angles, they just add to 180 degrees. Okay, remember the M stands for measure of. So this is measure of A, measure of B, and measure of C. Theorem 4.2, exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. Okay, remember this says non-adjacent. So angle 1 right here is an exterior angle. And the two interior angles that are non-adjacent to angle 1 are going to be angle A and angle B. Okay, you can't use angle C. You cannot use angle C because angle C is next to or adjacent to angle 1. So if you add angle B plus angle A, you add the measure of those two, they will equal the same measurement as the exterior angle, okay, the one that's not next to it. So those two equal the measure of angle 1. Example 3, find the measure of angle JKM. All right, so this angle right here is angle JKM. I want you to take this exterior angle and set it equal to the sum of these two interior angles and solve for x, please. And then when you get done, plug it in right there and see what you get. All right, so the exterior angle right here, that's going to be JKM. So we can say measure of angle JKM. And then let's add the two interior angles. This one here, we can just call it angle J. And this one here, we can just call that measure of angle L. Okay, so the one on the outside, that was the exterior angle. And the two here on the inside, those were the interior angles. And like we said, for the interiors, you have to choose the two that are not next to or adjacent to this one right here. All right, JKM is 2x minus 5. And that equals measure of angle J, which is just x, plus the measure of angle L, which is just 70. Okay, so we want letters on one side, numbers on the other. I usually subtract the smaller x. So I'm going to do minus x on both sides. X minus x cancels. And we want to get the 5 over here. So opposite of negative 5 is plus 5 on both sides. And this cancels. 2x minus x is just x. 70 plus 5 is just 75. So that is just x. And if we want the actual angle, you plug it in. All right, so you take the x and you plug it in right there. And that's going to equal 2 times x, which is 75, minus 5. 2 times 75 is 150 minus 5. That's going to be 145. A corollary to a theorem is a statement that can be proved easily using the theorem. The corollary below follows from the triangle sum theorem. All right, so it says the acute angles of a right triangle are complementary. That means they add to 90 degrees. So let's take a look. Okay, here is our right triangle. And they're saying the acute angles, basically the other two, when you combine the other two, A and B, they're going to add up to 90 degrees. Okay, they're complementary, and that makes sense. If the entire interior angles add up to 180, and you subtract the right angle, which is just 90, you're going to be left with 90 degrees. So 90 degrees is the number that's left over between A and B for the other two angles. Example 4, the tiled staircase shown forms a right triangle. The measure of one acute angle in the triangle is twice the measure of the other. Find the measure of each acute angle. Let's take a look. All right, so basically it's just a right triangle. All right, I'm going to redraw this anyhow. But you have one angle here that's a right angle, and the other angles here and here are the acute angles. Okay, so I'm just going to redraw this right triangle. Okay, so I just drew a right triangle, and it says the measure of one acute angle is twice the measure of the other. Okay, so if we call one angle, if we let one angle equal x, and the other angle is twice as much, what's the other angle going to equal? Well, if it's twice as much, it's just going to be 2 times x, or 2x. All right, so these are the other acute angles in the right triangle. All right, so one angle is x, and the other angle is 2x. Now we know all the angles inside the triangle. We know all the angles inside the triangle add to 90 degrees, add to 180 degrees, all right? The whole triangle is 180 degrees, but this one here is 90. So that means that this one plus this one also has to be 90, okay? Because 90 plus 90 would give us 180. So these two combined are just going to be 90 degrees. All right, so we have 2x plus x equals 90. 2x plus x is 3x, and that's 90. All right, and dividing both sides by 3. The 3's cancel. 90 divided by 3 is 30. All right. So you just want to take that 30 and plug it in. All right, so obviously the one that's x is just 30. And the one that's 2x is 2 times x, or 2 times 30. So that's just 60. Okay, do the answers make sense? Well, we said it adds to 90, and 30 plus 60 is 90. So it does check out. Okay, see if you can find the measure of angle 1 right here in this diagram. And I suggest you use the exterior angle theorem. The exterior angle is going to equal the sum of the two non-adjacent interior angles. So add these two and set it equal to the exterior. All right, so we have 40 plus 3x and that's going to equal 5x minus 10. All right, so the first two are the interiors. And on the right-hand side of the equal sign is the exterior. All right, so that's how I did that. And we're just solving for x. I like to subtract the smaller x. So the opposite of plus 3x is minus 3x. I'm going to do that to both sides. Cancels here. And then get rid of the negative 10. The opposite is positive 10. Cancels there. 40 plus 10 is 50. 5x minus 3x is 2x. And dividing both sides by 2. 50 divided by 2 is just 25. All right, so they wanted angle 1, so we have to take that 25 and plug it in. All right. So x is 25. So we're plugging that in for x. All right, so for this angle right here, we put the 25 in there. And 3 times 25 is going to give us 75. All right, again, we're looking to solve for angle 1. We know the angles inside of a triangle add up to 180. So if I add those three, it should equal 180. So we have 40. We have 75, this angle right here. And angle 1 we don't know. So plus the measure of angle 1. Okay, 40 plus 75. We have 180 equals 40 plus 75 is 115. And subtracting 115 from both sides. All right, it's the same as solving for x. Cancels here, and this is going to be 65. That equals the measure of angle 1. If you want to double check, 65 plus 75 is 140, plus 40 is 180. So it checks out. Okay, let's try problem 4. It says find the measure of each interior angle of triangle ABC, where angle A is x, angle B is 2x, and angle C is 3x. Okay, so let me draw that real quick. Okay, we have triangle ABC right here. They said angle A was x, Angle B was 2x, and angle C was 3x. All right, so we know the angles inside of a triangle add up to 180. So I suggest you add those three angles, set them equal to 180, solve for x, and plug it in. All right, so really we didn't even need to draw it. We know the three angles inside of a triangle add to 180. So we have x plus 2x plus 3x equals 180. Okay, obviously this is 1x, and 1 plus 2 is 3, plus 3 is 6. So 6x equals 180. Dividing both sides by 6, x is 30. All right, you want to take that and plug it in. So x is 30. 2x is just 2 times 30. So that's 60. And 3x, of course, is 3 times 30. So that's 90. So 30 plus 60 is 90, plus 90 is 180. Checks out. All right, let's try got it problem number 5. It says find the measure of the acute angles of the right triangle in the diagram shown. Let's take a look. All right, so I think this is the last one. This is the right triangle shown. Okay, we have the right angle. The other two angles are the acute angles. All right, we know that this one here plus this one here have to add to 90 because we already used 90 degrees here. So just add these two, set them equal to 90. Solve for x, plug it in. All right, again, the whole triangle is 180. All the interior angles add to 180. Okay, we subtract 90, and we're left with 90 degrees left over. So it's going to be 2x plus x minus 6 equals 90. 2x plus x is 3x. And that's minus 6 equals 90. Okay, add 6 to both. 6's are gone. Bring down your 3x. 90 plus 6 is 96. And divide both sides by 3. 3 into 9 goes 3 times. 3 into 6 goes 2 times. All right, so final step is to plug it in. X is 32. So 2x is 2 times 32. And that's 64. All right, plug in the 32 here as well. 32 minus 6 is 26. Okay, 64 plus 26 equals 90. So it checks out.